Good morning. Thank you.
Peter, you're sideways.
Is that better?
I don't know. It's kind of interesting with you being sideways. Everybody get your coffee?
I'm not allowed to drink coffee because I'm too short / too young / gonna stop my growth / that's not true / I really want coffee.
I've got coffee.
Well, if you don't drink coffee regularly, you're probably not used to it and may not like it. It took me years to develop the taste. I feel like we've talked about this before.
I've got my Slinky.
Yes. Nice. Oh, there's Henry. So everybody doing good this week?
Depends on which area you mean, because in school I'm frustrated with it, but in having more time at home, I'm happy with it.
Well, would you be frustrated with school if we weren't on quarantine?
No, not as much.
So why is it frustrating?
Because I don't have as much like things to do during the week to break it up. So it's like all I have to do is school.
School, play video games, go to school. This is weird. Oh, there we go. We have to have it set now, so I have to approve everybody to get in the meeting. So now I say approve, and then it says so-and-so left the meeting, and then they show up. So it's very confusing.
We can't see the brim of your hat, so it looks like a bandana. Okay, wait, now I can. It looks like a blue bandana with a blue shirt of the exact same color.
Yep. I like blue, in case you hadn't figured that out. Blue and purple. Purple's a cool color.
Black's the best, in my opinion.
I used to hate black. I don't hate black anymore, but it's just kind of tired. And so it's too popular, and that's one of the reasons I'm not a big fan of black. I do like it in some places. I mean, I wear black shirts and a black hat pretty frequently.
I think blue is more popular than black.
No,
No? That's surprising.
yeah.
I meet a lot of people who like blue.
Okay, wait, look at this room. Claire is wearing like a dark gray to black, could be counted as black shirt. Ben is wearing a blue shirt. You are also wearing a blue shirt. Therefore, blue is more popular than black.
Well, Mela is wearing purple,
That's not black.
right? And Henry and Karis look like they have red.
Yeah. Wait,
I
Claire, is your
can't
shirt
see Michaela.
black, gray or black? I can't
What?
tell.
Gray.
Which means that we have 3 grays, which means gray is the most common color.
I'm wearing a gray shirt from my church.
I'm wearing a gray shirt from the clothes
Gray shirt store.
place. Yeah, a gray shirt store.
Hand me down.
No, we don't talk
I got
about that.
my Demolition Ranch shirt, which is pretty much what I wear all the time. Not this one, but this one or another one that's Demolition Ranch. And my Broncos cup. If there's any football this year.
I
There's
wouldn't
Sam.
care if there wasn't any football.
I just
I
like
don't care
football as well.
about football.
There's Sideways Sam. Morning, Sam.
What?
Hello.
Okay, we're still waiting for a couple more of our friends here. Think we're missing, I know Lily. And
I don't think Sterling's here.
Sterling just showed up. There he is.
Oh, yeah, I see
I
him.
am here.
Oh,
There's Sarah.
we're missing Brady.
Missing who?
Brady.
Oh, Brady. Yep. Brady and Lily.
The strawberry is in officially.
Yeah, I see a strawberry.
Connecting to audio, but strawberries don't have ears, so that's pretty sad. Good luck with that little strawberry.
Sarah, you're on there twice. Now I see you on one, and the other one is connecting to audio.
Wait, what? She's the strawberry? Whoa.
Yeah, Sarah is the strawberry, and then I see the real Sarah, so I'm not falling for the strawberry one.
Sarah,
Not
can
sure.
you even hear us?
I'm not sure she can hear us.
Give an acknowledgement of existence. Is the strawberry taking her audio?
Yeah, I think it is. It's absorbing
I
the
would
sound.
like to help throw you in the pool.
Yeah, there's
just
something
think
wrong with
it's connected to my
Sterling's
phone
head.
as well, so I'm restarting my phone.
Oh, there's nothing wrong with his head. You can just change your background. Look at my background. Ready? Boom. Whack. Office background, except it's kind of choppy because my curtains are white. Yeah. It's
Yeah,
black
I don't
magic.
I don't think I can do that on mine because I'm working on an iPad.
Sterling, you stole my picture. That's just sad. Oh, there we go. Yeah, dude. Do that one.
The second Sarah went away. There can only be one.
Rich people in 2021.
Well, the ones that connect
No,
twice.
the ones with like loads of toilet paper. Look at his
Oh.
background.
Well, I can't make my background change that I can tell.
I know you can. You just have to go to video settings, then background, and it's. I mean, it's pretty simple.
Well, it may not let me do it because I'm working on an iPad.
Oh. No, I'm positive you can. I was on a Zoom call with my youth group last night, and one of my friends uses an iPad.
I can do this. I don't know what it did, but I can.
Yeah, you make a reaction. It's called, I guess.
Little hand clapping emoji showed up by your head.
Yeah, well, it doesn't show on my screen, so I have no idea
So
what I
here's
did.
what I do. I go, you know how right next to the mute button there's the video options?
I see one that says stop video.
Yeah, so
So
there should be like an arrow right next to that.
There's not for me.
Well, I think it's because, Sarah, are you using Zoom from a computer?
Yes.
Okay, so the reason I like at first is it like when you can only see one person at a time?
Yes.
No,
Okay,
you can
so
go into a gallery mode.
you don't have no. Here's the thing, because I used to be like that, Finn. Because there is no gallery view if you don't have the Zoom app installed on your computer.
Yeah.
I'll download the Zoom thing.
Yeah. I couldn't change my background either until we downloaded the Zoom app. So that may be it. If you
well, on mine it just doesn't give you that option on the iPad, which is okay. I got a pretty good background as it is. Some of my artwork up there.
Sterling, what is going on?
Many things beyond your understanding.
How do you make a GIF a background? Or is that a video? Yeah.
Okay, well, I'm not sure where everybody else is, but we're going to go ahead and get started. and they'll probably show up a little bit, but it's 8:10 and we got to get things underway. I'm going to say this: last week there was some of the other classes kind of gotten, some of the students in the other classes kind of got in trouble. Oh, there's Lily. With our administrators because they were doing lots of chat, which I've disabled that, so y'all can't chat among yourselves.
We couldn't before either. It just went to you only.
I will say that I'm just going to say this is that the background thing, it's cool, but we don't need to be distracting other students from paying attention by doing that. So let's, right now it's okay, but after, once we get underway, let's just save that for later, okay? Anybody have any thoughts or questions before we dive in?
Yeah. Do we have to dive in?
Yes.
Cedar, why do you have to ask these stupid questions? I mean, like, I know somebody has to do it, but why
Einstein
it
did
have
that.
to be you?
Einstein asked questions, therefore, Peter's Einstein.
That's some questionable math, Ben.
That's not how it works. Check your logic.
My logic has been checked thoroughly.
So, so you're saying that after, yeah, because my brother, he's in the physics class, and that one got hit the hardest by the email because they literally in the email, they literally pointed fingers to the physics class.
Did they, did that
Yeah.
say that in the email?
In the email that was sent out to everyone.
Yes. So yeah, that's, we don't want to be the next one. So,
Well, you had the chat modified from the start to where we
yes,
can
I
only
have.
send
That's been
messages to you.
that was intentional. It's just, you know, it's this format's different, and we have to learn. And I know that y'all, you can, when you have that opportunity, we all tend to do those kinds of things. Just me and one of my coworkers actually will have text message, be texting each other sometimes when we're in work meetings. Now, we don't do it to excess, but somebody makes a comment that hints to an inside joke between me and my coworker, and so we will, you know, it's not like doing those things is necessarily wrong. It's just when it becomes where it takes over and distracts other people from learning. I mean, because that's what we're here for, is we're meeting and we're doing this, and we want to learn. It's not just for fun, and I want it to be fun, and but we have to put some parameters on it. It's just kind of like playing a sports game. If you have any kind of or any kind of game, if you have somebody who's not going to follow the rules, then the game isn't fun. It distracts from it. So the same is true for things like learning in classes. If somebody wants to break the rules and create issues rather than learn and pay attention, then it makes it where we can't have fun, because then the teacher has to get mean. And thankfully, I don't have to do that, at least not very much. I did get a little bit mean in the email earlier this week, and so I've actually since learned that I know that I see a lot of the files come in and it's got your name tagged in front and your name tagged in the back. And I was saying something about that in the email. And I realized that I think that it's Dropbox that's doing that, because everybody's is pretty much consistently. It tags your name on the front and then it tags your name. So I end up having to rename files anyway. So, but in any case, if you got the back end the way I have asked for it, then it all works out okay. It's not too hard to do.
If
But
Dropbox automatically puts the name in the front, then why don't we just not put the name in the middle and reorganize your system of titles so that we don't actually put our name on it, but it does?
well, no, that's not going to actually be helpful, because what that'll do is then what I'm trying to do is create a system that actually sorts all the files in the folder by assignment type. So everybody's on your own questions, all stays together. So when the grading assistants are checking on your own questions, they can look and see everybody's turned it in. And then when they're checking study guides, all the study guides are all together. So because they check things by type, they don't check it by student. So that's just the way it works, and that just makes it work more smoothly for getting the grading done. So that's okay, and it's not a big deal if you got the back end named correctly. Then it's not too hard to go in there and just take the name off the front, and then everything's sorted. Also, I can see right up front who's everything that's been turned in this week. And then when I go in to rename stuff, it's not too difficult. Just takes a little bit of time, but I'm not going to be able to get away from it completely. So in any case, let's pray, and then let's talk about making some noise. It's what we all want to do, right? All right. Father, we thank you for this day you've given us. We thank you for another opportunity to sit down and learn a little bit about creation, learn a little bit about sound and waves and oscillations and propagations, and just to make us more knowledgeable about the world that you have made for us. And just pray that as we learn and study, that you would help us to just endure. And as we go through these days where we're sequestered in our homes, that we would, if we have extra time, that we would take that time to grow and learn, and to pray a lot, that we might move the hands of history, that we might say that we were there and we had an impact. And just pray that you would give us understanding, give us wisdom in all things. And we ask these things in Jesus' name. Amen. All right. I put my glasses on so I look smart. Put my hat on so I look cool. All right. Rub my eye. You're not supposed to touch your eye. I washed my hands yesterday sometime, like 14 times or 50 or how many ever it was. Okay, let me get my notes. Where'd it go? There it is. All right, we were talking about sound, as I'm sure you recall. Last week, waves and sound. We have a couple of let's see. I had you do a couple of experiments this week. Actually, you just had one to turn in. What was the experiment you turned in today or this week?
14.3.
14.3. What was that experiment?
Wavelengths and sound.
Was it one involving a bottle like this?
Yeah, it was that one.
Okay. Cool. And then did anybody have a chance to do either experiment 14.3 or 14.2?
Remind me what those ones were again?
14.2 was the one where you would go out in the street and hit some rocks together or get some distance apart, and you're trying to calculate the speed of sound based on when you see the noise makers hit and the time you hear it.
No, was that one required?
No, I did not make that one required, partly because it required you to get out and go away from your house, and since we had stay in,
We're all our own little cave troll that's allergic to sunlight.
yes, get out of the basement. But since those were, I made them optional, but if you have some areas, if you're out in the sticks or something like that, you can actually still do that experiment. So you can actually check and try to calculate the speed of sound. It's a fun experiment. I did that a couple of years ago with my oldest two science students. And we just went out on the street, and they went all the way to one end of the street, and I went to the other end of the street, and I got two pieces of 2x4 and hit them together. So if you can find some time to do that, I would encourage you to at least get out and try to observe that effect. And hopefully you have actually seen that before. Say, I remember when I was a kid, some of my neighbors down the street would be playing basketball. They had a little basketball hoop in their driveway. So they would actually be out there playing basketball, and I would actually see the ball come down. They'd be dribbling the ball, and the ball would hit the ground. It'd go down and hit the ground, and then the sound would come back to me about the time the ball was back up to their hand. So it looked like the sound was coming from the ball hitting their hand, but it was from the ball bouncing off the pavement. And that's because there was some time delay between the sound bouncing off the ground and getting to my ears when I was a few hundred feet away. So if you haven't ever observed that effect, it's actually kind of fun. It's one of those things that makes you, well, that's weird. And it's somewhat intuitive, I think. You can actually, when you've heard it or when you've seen that. So anybody actually ever observed that before? Claire, I see. I can't see all of you all at the same time. So
Yes. Just say yes if you've observed it. Yes.
Yes.
Yeah.
all right, cool. So that's something that's always been a little bit fascinating, but that's all related to the speed of sound, because what you can see, the speed of is what you can see. It depends on the speed of light, and what you can hear depends on the speed of sound, and sound is slower than light, obviously. So if you can do the experiment, great, or if you can just go out and just play with that, see when you see something making sound and then hear it, and there's a big difference. That's at least interesting to observe. Okay, let's see the other experiment, and we'll talk about it in a little bit. The other experiment is the Doppler experiment, which involves your parents setting you on the side of the road and then driving past you with the horn blaring in their car. So it's usually a favorite of the neighbors. I actually when I did this with my kids, I took them out on a dirt road just outside of town and drove past them at about 35 or 40 miles an hour with the horn blaring. And I went to a place where there was no other houses, so I didn't really get in trouble with the officer of the law or with my neighbors. There we go. And anyway, that's another fun one. So hopefully, if you haven't, you probably aren't going to get a chance to do that one right now, but you can actually you might be able to observe it. Well, we'll talk about the Doppler effect, and I'll give you some other examples here in just a little bit. Okay, so now we talked just briefly about the speed of sound. Did we talk about this formula last week, the 331.5? I don't remember us discussing that.
No, I don't think we did.
Okay. I think we did get to this slide where we talked about the speed of sound depends on whatever it's traveling through. But we didn't actually talk about the speed of sound in air. I remember I got my little measuring device out, and but we didn't talk about this little math problem here. Let me grab my book. Okay, hold on a second. Brady's trying to
We're
join.
gonna acknowledge that child screeching.
Yeah, that was pretty weird. Not only
What's
that, but Davey's gone.
The first to go missing.
No,
Yeah,
she's not.
back. Okay, we're good.
Did you say you heard a child screeching?
Yes. Yes, I did. Did you
We
not?
heard your tortured children. We heard them.
Well, I have twin boys that are 4 years old, so they make lots of squealing and screeching noises. Now they're on the other side of the door from me, so it's somewhat muffled, and I'm not paying any attention. I've been actually working here in this room like this for the last 2 weeks, so I must have adjusted to it, and I'm also used to them doing that kind of stuff. So that it's not that I'm ignoring it, but I'm ignoring it.
Oh yeah, that reminds me. Just be serious. I found your YouTube channel.
Oh, you did?
Yeah,
too.
I saw your video of you surprising your kids with toilet paper.
Talking
Mhm.
about ignoring things made you think of his YouTube channel?
No, him just talking about his family and his kids.
Yeah, that actually didn't have all of them in it, so there was bunches of them.
Did anyone rewatch the previous classes? Anybody?
I don't know.
Me.
Are those
I
on?
did. I just randomly rewatched them for
I did.
an unexplicable reason. But okay, we got 2 other people.
Mark Rober is giving out science lessons.
Mark Rober. Yes,
No way.
Cool.
I've
Remind
wanted
me who
to watch
that
the
is.
one. I've wanted to watch the one by him about whether farting makes you weigh less.
I saw that one.
I didn't
It's
actually.
pretty good. I'm not gonna tell you the answer so that you watch it.
But yeah, they're 30 minutes long, so me having 30 minutes interrupted during a day is that's been the challenge. So I hadn't watched them, but I probably will sometime. Let's see. April 2nd. No. Let's see here. Let me just text it.
Sterling, we can only see the part that says I may be stupid.
That's the only part.
Oh, okay. I didn't know if that was like there's a part at the bottom or not.
No, this is just me and my fellow Reginald over here.
Your fellow what?
Reginald.
Bro.
This is fine. Why did it get so quiet?
Because
What are we?
I'm trying to help Brady get connected.
Just like somebody do cricket sounds with their mouths. There's something. Just
There's
do
a
a
cricket
cricket sound.
sound effect in here. Please tell me there is.
Gotta do the Kronk crickets.
Kronk. Good old Kronk.
Okay, hopefully that'll work. All right. So, all right, this formula here, the 331.5 plus 0.6 times T, and the T is temperature in Celsius. There we go. There's Brady. He's connecting.
Brady joins. Hang on.
He does.
Howdy, Brady.
Howdy do. Howdy do.
Howdy doodle.
Howdy draw.
Upgrade.
Okay. So this formula is, as I said, it tells us that it depends on temperature and it's actually directly proportional. So the higher the temperature of the air, the faster sound travels. That's pretty straightforward. And we can use that, as I showed you last week, we can use that information and that knowledge because it's always the same. The speed of sound depends only on the temperature. So as long as the temperature is not changing, the temperature of the air is not changing, then the speed of the sound would be constant. Okay, so if your room temperature is 70 degrees, even if it varies a little bit, 70 to 71, 72, it's not extremely sensitive to that temperature, but it does go a little bit faster if you bump up by, say, 1 degree, then the sound is going to travel just a little bit faster. So it's not going to be enough, though, that we couldn't use it to accurately measure distances using sound. So I showed you my sonic ruler last week, which uses that little clicking sound and then records the time it takes for the sound to bounce back. Then it's using that depending on the temperature. So it's consistent, and that's also another thing that we can do with it is if you see something like a lightning flash, and then you hear the thunder come a few seconds later, then you can actually tell approximately how far away that lightning bolt was. Or lightning, sheet lightning is the ones in the clouds. A lot of times that's what it is. There's more lightning inside the cloud, in my observation, than there is in the lightning bolts. Okay, so a couple of useful things that you can do with the speed of sound. And then we talked a little bit about the different speeds from table 14.1 in page 351. So I'm not going to rehash that. All right, let's talk just a quick second about supersonic speed before we get to talking about pitch. We'll talk about supersonic speed, and that is simply, well, actually, that's a vocabulary definition. So who wants to tell me? Claire, what is supersonic speed?
Any speed that is faster than the speed of sound in a substance of interest.
he proud of the fact that he knew that you knew and immediately called on you?
No, she raised her hand.
Nice job, Ben.
Wait, how did you even tell? Were you not looking at your own slides?
No, I can see some of your screens here.
Wow.
Oh, now I can see everybody.
You broke it.
I broke it.
Yeah, I can't see the slide anymore. I just see people.
Sterling, why do you have a big bear as a background?
It's not a bear. It's a Doge.
Yeah, you're right, it is.
Okay.
Playing Lego Star Wars. Leave him be.
Okay, so something that's supersonic then is when it gets faster than the speed of sound. So like a supersonic jet, it travels faster than the speed of sound based on the temperature of the air. And then some interesting things happen when that occurs. So there's two examples that I can think of right off the top of my head that where we encounter supersonic speeds and they have observable impacts. And that is most notably from your book is the sonic boom. Anybody ever heard a sonic boom?
I have.
I mean, maybe one time I went to an air show, but I'm not sure.
They normally don't actually. The jets will actually sometimes go supersonic at air shows. They'll do that. They'll come do a supersonic flyby, which is really cool to see, because the airplane will fly past you and you won't hear anything. And so it'll come past you and it'll be completely silent. And then the sound catches up sometime later. And that's just really, really cool to be there and observe that. But a sonic boom occurs not when they're at an air show. They will actually just basically just exceed the speed of sound. So they'll go a few miles per hour over the speed of sound, but they won't actually go much over. And a sonic boom occurs when they exceed the speed of sound by a certain threshold. So, and I don't know what that is off the top of my head, but I know that they have to be going a certain amount over the speed of sound before they'll actually create a sonic boom. But a sonic boom, so you're not likely, the point I'm saying, I guess, is you're not likely to hear it at an air show, but you will see a lot of times when you will actually hear a sonic boom, you won't actually even know it's coming. You can't see the airplane. We actually have, I've heard a number of them. Actually, I've heard a couple in Denton, and it'll scare the bejabbers out of you because it's very loud. It sounds like thunder all at once. So, I mean, it sounds like maybe a giant explosion. It's as loud as thunder, but do you think about it sounding like a thunderclap just compressed into one single thing? So there's no rumble, it's just kaboom. And it sounds like literally a building explodes, and it will scare you if you hear one. Now, I worked out at an office that was out in the country, and apparently it was like a little corridor where they actually like to do supersonic testing of some sort. And so there was a number of times we'd be out there, and it building the sonic boom would hit, and windows in the building would literally rattle because it was so loud of a sound. So and it is very impressive whenever you actually hear it.
I heard one once.
Who's saying that?
Michaela,
How can you describe it?
how you said it was like thunder and we had no idea what it was.
Was this at your house now, or where you live now, or is it some other place?
Where we live now.
Yeah. Yeah, that's where kind of the area where my office was, west of Denton as well. And yeah, I haven't heard one in a long, long time, but I've heard them in Denton, but it's been more than 10 years ago. So any case, that's hopefully you get to experience that at some point in time, because it's pretty fascinating. You never know right immediately when it goes. You think it's like somebody blew up a gas tank somewhere, but you start looking around for buildings to fall over somewhere, because it's just that loud. Another place where you will can actually hear sonic booms in a much, much smaller scale is if you ever get do any shooting guns. A lot of times the bullets can actually exceed the speed of sound. And when they do, they make a little miniature sonic boom. And it sounds more like a clap or a crack sound. Yes. So if you there's a few companies that make what's called pellet rifles that just work on air. They're not actually firearms, so they don't use an explosion to accelerate the bullet, but they actually use compressed air to quickly accelerate a bullet, a small pellet. And there's a few of them that actually can exceed the speed of sound with that. And that's because the guns themselves are actually really quiet. It's a good place to actually hear the sonic boom created by a bullet, but it's a smaller sound. But in any case, those are
airsoft?
No, not airsoft, a pellet rifle.
It shoots little tiny like metal pellets that you don't
Yeah.
want to get hit by.
Yeah, I've heard of those.
I have one that the feet per second is higher than a 22.
Well, now.
Yeah, I do too. I have one that'll shoot 1,200 feet per second, and your average 22 is right around that same range.
Mine shoots 1250.
1250, yeah. Yeah, it depends. It depends on, you can actually shoot a 22 pretty fast, depending on what it is. They have ultra high speed ones that'll actually, if you shoot them out of a gun that's got a long enough barrel, then it'll actually can get up in the around 1,300. But yeah, that's about the range of it. Now, I think 1,300 feet per second is pretty close to the speed of sound. So you have to get up over that. So something in 1,300 to 1,400 feet per second range on a pellet rifle is what you'd be looking for one that actually can break the sound barrier. Okay, anyway, let's move on. Let's talk about pitch, not baseball. Okay. Pitch. What is pitch?
I have the definition.
All right.
An indication of how high or low a sound is, which is primarily determined by the frequency of the sound wave.
Okay. How high or how low a sound is. And you did a little experiment to demonstrate this. Now, this one actually is a little bit harder to actually visualize, but you can see, you can at least hear it. And I've actually taken the liberty to see my old see, you can't even find these anymore. This cool little Dr. Pepper bottle with the red and yellow lines on it. It's a old Dublin Dr. Pepper. I've kept it forever. I don't know how long I've had that, but a
I
long
think
time.
you can find them in Denton Square at Atomic Candy.
But I
Yeah,
don't think
I was
you,
about to say. I know
can
somewhere
you
you can find them, and I think it is at Atomic Candy.
can you buy them with this bottle design with the yellow, and I've seen them more recently. I mean, you can get these little bottles at Kroger with but they don't have the red and yellow colorings on them. They're all just white. In any case, but you hopefully got to do this where you take the bottle, and unfortunately this one doesn't have Dr. Pepper. If we were meeting, I would have brought some of these to class and we could actually done the experiment with real Dr. Peppers. But so I just have water here, but and I washed the bottle, so don't worry about it having any kind of viruses on it. But you can see it's full. Here's the water level in there. So see if I can do it. You have to blow on it really hard when it's full. Nope. Nope. Gonna have to pour some out. It's too full. Pour it on the floor.
It's only ever supposed to be
3/4
max
full.
3/4 full. It's not
Yeah.
never supposed to be all the way full. And Sterling, why the voice mod?
You're
there?
not supposed to have it all the way full. It was only 3/4 of the
I
way.
just said that.
Well, that's.
Oh,
I just
Yeah, I
got
just said it again, Finn. Guess what?
Now the water level is about right. It's right here where my finger is. I don't know if you can see that really well. It
Oh,
depends on how clear
The
the
bottle
picture
I
is.
used had a longer neck.
Yes. Now I could have. It was actually the force from the air was actually making the water come back out. So I poured it out, but now you can see it work. So it did a little flute sound. So you just pour some more on the floor. I hope my wife doesn't mind me pouring water all over the floor. She'd
You
probably say, well,
serious?
you got to sit there for the rest of the day, so it's your problem.
I'm 90% sure you're just pouring it through a trash can.
And you're 100% sure?
90.
90?
pan down the camera. Not you, Cedar.
I don't have any pans in here. So you notice the change in sound, right? Can y'all tell the change in the sound? Why does the sound change? Now that's the question. Because we know, I mean, it goes from a high pitch to a low pitch. Why? What makes it change? Claire, what do you think? You're muted.
The air, the air that travels in the bottle has to travel up and down to make the frequency either short or long, whether or not how much water is in the bottle.
Okay.
Sound doesn't travel well in water or liquids, so it changed the way it changed it a little because of that.
Does it change it because of the water? Is that what the question is?
No, because the water takes up room in the bottle, and then when the sound goes in and it starts bouncing around, I think it's because it has less room to move, resulting in shorter wavelengths.
That seems like
The shorter wavelengths make a different sound than the long wavelengths.
Yes, the shorter. Which way is it? Shorter is higher or longer is higher?
I think it's shorter. Shorter is higher.
Shorter wavelengths make higher pitch sounds. So
science.
As we increase this air in this space in here, the air traveling down into the bottle and then back out of it determines the frequency of the sound coming across here, because it's the air traveling across there that's being modified by the pressure wave coming through there. So it's actually all pretty complicated mathematically, and because we're looking at a three-dimensional shape or three-dimensional space in here, that all has an impact to it. But what the net effect is that since it takes longer time for the wave to travel down to through the larger volume, because there's more volume there, then that actually reduces the frequency here. So it lowers the wavelength as we pour more on the floor. Oh, you can't see it. Still can't see it. Oh, it's splashing everywhere. So as we continue to dump out the water on the carpet, and that's pretty much all of it. So that's as low as that's going to get. All right, another place where we can see the pitch of something change is my old friend here. And if you saw my YouTube channel, you would have seen that I have a video on there of me actually playing the guitar with a buddy at church for the little kids. So I disclaimer myself here by saying that my primary audience is young children, like 2 and 3 and 4-year-olds. And so my musical ability is appropriate for that level, but so I'm not going to actually try to make
it. As long as it's not Baby Shark, I think we'll be fine.
Oh, I can actually play Baby Shark on the guitar.
Oh God, Finn, what have you done?
No, please.
I didn't mean it like that, no.
Play Baby Shark.
Vetoed. I veto that.
Play
Okay.
chocolate cookie.
Yeah, I can do
Yeah.
that.
I do not veto that.
Do it.
That's the song I'll approve of.
That I can do that one too. Okay, but unfortunately I can't really show you this too close and be able to demonstrate adequately what I'm doing. I'm trying to get in a good spot here with my camera and seat height. There we go. How about that? Okay, as you probably know, this instrument works with strings, and there's 3 factors that actually determines the sound pitch. One is the size of the diameter of the string. So I have, if I bring the camera close, I have up here on the top, I have the large diameter strings, which you can actually see more clearly here. Then I have the small diameter strings here on the bottom of the guitar, because I'm right-handed if I turn it over, obviously. But so I'm right-handed, and so the bottom string to me, you can get left-handed guitars that's got the same arrangement, but anyway, this one actually is going to make a high pitch, partly because it is a smaller diameter. Now, the other 2 factors that impact or determine the pitch made by a specific string is the length of the string. So here is the one end, and here is essentially, this is the top of the fret is actually the one end of the length, and then the bottom of the fret down here is the other end. So that determines the sound. And then the last factor is the tension, which is adjusted by the tuning. So if I change the tension, then it changes the pitch of the string as well. And all those do is regulate the, oh wow, I put it back where it belongs exactly. All those do is regulate or determine the frequency at which the string vibrates. Now, the other thing that I can do to actually vary that is, or the way that you make music with a guitar is by varying the effective length of the string by pressing on the strings and shortening the length of it by the fret distance. So each one of these frets is spaced at such a distance that it makes a exact change, a precise change in the frequency or the length of the string, such that it makes a precise change in frequency. It's actually pretty, again, the math of it is a little bit more complicated, because you can see the fret distance is longer at this end than it is at this end. They get really skinny up here, but those are all the different things that you can use to control the pitch of the string. So you can play it open, and that doesn't sound that great, but you can shorten some of the strings and vary some of the pitches of the strings and make a different chord. So, something is not right there. I guess not too typical. I think my B string is out a little bit, or the E. I'm not going to tune it today, right now. So that is pitch of sound. Now, again, let's see, on my notes there, it says 2 things determine the pitch of the sound: a wavelength and the speed. Now, what do you know about the speed of sound, say, in the room where I'm sitting? What can you tell me about the speed of sound in this room?
We actually don't know where you are, so like if you're in space, things might be different.
Well, you can hear the sound, right?
Yeah.
Yeah.
So that means I'm not in outer space. Why? How do you know that? How can I make that statement?
Social distancing.
Because there's no air in outer space, so the sound waves have no medium to travel through.
That is correct.
Jealous. The people on the International Space Station don't have to do social distancing.
Yeah, they're probably
They're all vibing with each other.
well, they can't really get very far apart from each other anyway.
Yeah, but there's like no way for the virus to even reach them.
They can get very far away. They just have to open the doors and go out into space and float away from each other.
I'm gonna pretend I didn't hear that.
I suppose that's true.
Yeah,
this thing.
It's true, but it's dark.
Claire is like Sarah is over here. Just if they jump out into space, they'll have plenty of distance.
Okay, but let's go back to my question though.
Well, they will.
What can you tell me about the speed of sound in the room that I am sitting?
The speed of sound should be
and I will tell you this, that the temperature is not going from 0 degrees Celsius to 90 degrees Celsius and back.
What is the temperature in your house, and I can figure out how fast it is.
It's probably about 75. I got the window open, so it's probably getting a little cooler because it's nice and cool out this morning. Beautiful morning, by the way. So, but if the temperature is constant in the room, then you can say, what can you say about the speed of sound in the room?
That the speed of sound will be relatively the same.
It is. It would be. The speed of sound will be constant. If
I got 376.5 meters per second.
Now, did you convert the temperature I gave you into Celsius?
Dang it.
It doesn't really. But that's not the point. The point is that the speed is constant because the temperature is constant. If you go back to that equation, if we go back and look at this equation, the speed here depends only on temperature. So if the temperature is staying the same, if it's not changing, then the speed of sound, we can calculate it 100 times and it'll always be the same. So it's constant. Does that make sense? Okay, so if the speed of sound is constant, then what is changing that makes the pitch change?
Wavelength.
Wavelength. Because the speed of sound depends only on wavelength and speed, and we've determined or learned that speed is constant, so it isn't changing. So then if I'm going to vary the pitch of the sound, then the only thing that I can change to make the pitch different is by changing the wavelength. Okay? And if you go back, you think about this, it all depends on frequency, which is speed, the little v, over, forgot my equal sign, over wavelength. So if the speed increased, then that would change the frequency too. But like I said, we're talking about the speed of sound, and I'm in a room with a constant temperature, so that does not change. So the only thing that can change is the wavelength. All right, I've said that a couple different ways, so hopefully that's clear. And there's the equation right there, frequency equals speed divided by wavelength. So that determines the frequency. Now you remember, the frequency of the sound is how quickly the waves are passing, coming past a fixed point. So it could be high frequency like this, or low frequency like this. And the higher frequency means more waves passing a point at a given time, okay? Couple more points about pitch. Frequency is directly proportional to the speed of the wave. So if the speed of the wave increases, then the frequency goes up. If the frequency goes up, the pitch goes up. And then frequency is inversely proportional to the wavelength, because the wavelength is in the denominator on that equation. So just like this, if we do frequency equals V over lambda, and say our speed is 350 divided by, say, 4. I'm just making up some numbers here. That'd be a really, really long wavelength, 4 meters. Okay, if I increase this number, then what happens to the frequency? If I increase the wavelength, the frequency goes down, right? Because it's 350 divided by 4 would be a number. 350 divided by 8 would be a smaller number. So that would be, right? 350 divided by 8 is less than 350 divided by 4, which is also less than 350 divided by 1. Okay, so if I increase the wavelength, so if I increase the wavelength, then the frequency goes down. If I decrease the wavelength, the frequency goes up. So that's what it means. The frequency is inversely proportional to the wavelength. If wavelength increases, frequency decreases, and vice versa. Make sense?
Sure.
Okay. Now let's talk about the Doppler effect. This is the one where this is the part where you would have gone and done this experiment with your parents driving by with the horn blasting in the car, which I still think you should do it because it'll be fun. Maybe when coronavirus is dead, or at least eliminated as a threat to all of us. Okay, so remember I just told you the important point to remember about at this part of the discussion is this point right here. Let me underline it. Frequency is directly proportional to the speed of the wave. Okay, so if we increase the speed of the wave, then the frequency is going to go up. Frequency goes up, pitch goes up. Okay, so remember that, keep that in your mind. Let's talk about the Doppler effect. Now let's put the equation back on the wall here. Frequency equals speed over lambda. Now it turns out that even though the speed of sound is constant based on the temperature of the air, the speed that the sound travels of its own is constant relative to the air temperature, based on the air temperature. We can actually change the speed of sound by attaching it to a traveling object. Say a car horn, because a car horn is attached to a car and cars move. So if the car is traveling along, then it's transmitting a wave. You push on the horn button, then the horn fires or goes whatever. How do you describe a horn noise? The horn blares. There we go. That's a good word for it. The horn blares, then that sound, the source of the sound is moving. If you're driving along the road, the source of the sound is moving as you drive. And so the speed of the sound is actually changed by the speed of the vehicle. And with sound, because the speed of sound is not crazy high, it's fast, but it's not so fast that the speed of a vehicle would have no impact or a smaller impact. Okay, disregard that. But we can change the pitch of the sound a little bit by attaching it to a moving object. So let me see if I can make this more clear. I'm going to go into whiteboard. All right. So if you have a car, a funny looking car, here's the window, there's one wheel, there's one wheel, and let's just pretend that this is the front of this ugly car, and it is blasting its horn. And it's emitting a wavelength at a speed of, say, let's say the car is traveling at a speed of about 20 meters per second in this direction. And here's you. In your ear, and the sound is traveling. Yep.
Good gosh. This
Oh my.
physically hurts me. Just the ear. The ear. Oh
And the
dear.
hair.
I'm
Did you guys
enjoying
hear
this.
my chair squeaking?
Yes, we can all hear your
Yes.
very talented chair.
Okay. So if the car is traveling along at that speed, my M is terrible, so I have to redraw that. There we go, better. 20 meters per second. And then the speed of the sound, let's just assume that it's 350 meters per second based on temperature. So little v equals 350 meters per second. So now if the car is traveling in this direction as I've drawn, and the sound is traveling at 350 meters per second, then the sound as it gets to you is going to sound like the sum of those speeds. So the sound when it reaches your ear is going to be effectively traveling at 370 meters per second. So then going back to our equation, frequency equals speed over wavelength. What we have done is we have increased the speed. So your frequency of the sound is directly proportional to the speed. If you increase the speed, then you increase the frequency. So what your ears are going to hear as the car is traveling towards you is a higher pitch. Because of the relative speed of the car. Now there's another key element to the Doppler effect, and that is if the car is traveling away from you, the effect is the opposite. So I'm going to leave you standing right there, and I'm going to turn the car around, and we're going to make so it's a reversible direction car. It can drive both ways. So it's now traveling and it's blasting its horn, and it's traveling in the opposite direction.
It's about to run over the guy.
It's traveling in the opposite direction, Finn.
Okay, so now if in this example, when the car is traveling away, then the sound is being emitted, is actually still coming out of the vehicle, but the sound can actually be traveling because it radiates from the car in circles. Then the sound coming from the car is still going to be traveling toward our guy. But it's going to be, the speed is going to be reduced effectively by the velocity of the car. So now, instead of being 370 meters per second, the sound that we will hear will be 330 meters per second. So there, in this case, we have actually reduced the velocity of the sound and therefore reduced the frequency. So now the pitch that we hear is lower. Does that make sense? I'm seeing some thumb ups. Very good. Does anybody have any questions?
I have a sort of off-topic question that I forgot to ask in the beginning. So, we were gonna do a Hangout thingy, a Google Hangout, and
Yes.
so there was a lot of debate over like doing it. I don't remember what Sarah said. Some like website or something that's quote unquote secure that everyone can get. But you have everyone's email since you send us the science email. So why don't you just create a group chat hangout thing?
Well,
All of our emails.
there's a the answer to that question is a little bit more complicated. For one thing is we have to maintain a very high level of accountability in sim science. And so whatever I set up has to be available, and we can still do this, but I have to make it available to the sim science board so they have the ability to oversee any of those. And so what I actually did talk to our webmaster about this very thing. And there is actually built into the Sim Science website, there is a method or a tool where we can actually do this, but I'm not sure it's quite set up. And we have to figure out exactly how to use it. So I think, and it would obviously be secure. It will be monitored, and so it meets all the requirements. We were testing it to determine, or we were looking into it to determine if it was actually going to function for what we had talked about doing in class. So that just haven't got the answer yet, but I'll follow back up with our webmaster guy and find out what he's learned about that. So
why does it have to be so like secure and like I don't know what to call that, like monitored? Like I don't mind if it is. Like you can be in the hangout, I don't care. But like, can it just be like a hangout with friends in it?
Well, it could, but again, it's kind of it's a function of the day and age we live in, and so I can't really go into a lot of the details of it at the moment. But it's just, this is the way. If it's going to be in the context of sim science, then we have to go about it in this fashion. So it's the right thing to do. That's kind of what it really boils down to, is if we're going to do it, we're going to do it the right way. And so the Bible counsels us to be above reproach, or to be blameless in all that we do. And so we, as sim science and as representatives of Christ, we have to do things that will allow us to be above reproach. So that's may not be the answer you want to hear, but that is the correct answer. Okay. Anybody have any questions about the Doppler effect? Okay, now I get to kind of humiliate myself by, well, we'll see. Let me give you a couple of examples. Since you probably haven't been able to do the experiment and have your parents drive by with the horn blasting, then let me give you a couple of examples. You have observed this most likely before. And the number one thing where you hear the Doppler effect, and you can observe the Doppler effect, is airplanes. Ever since you were a little kid, you have actually been mimicking the noise that airplanes make as they fly over. You know that let me go ahead and just do it. You know, they come across, and I had to put my hand in there to do this, you get the full visual effect. So as the airplane flies over, you can hear the pitch. It comes in at a higher pitch, and then it actually gradually changes as it flies by you. And as it goes by, you hear a much lower pitch once it's past you. So, like I said, even little kids, they pick up on this sound. My 4-year-old boys, they can have their toy airplanes and fly them around, and they know exactly the right sounds to make. If it's a jet, they know the sound it makes. They can tell the difference. But the reason that the jets and airplanes make that sound as they go by you is the Doppler effect. And the reason it gradually changes is because we live in a 3-dimensional world. So the sound waves are coming at you as the airplane comes by, and then the Doppler effect is reduced. So when it's directly straight, right even with you, as it's flying by, as it's right even with you in your ears, then the pitch that you hear will be the actual pitch of the airplane, as if it were sitting on the ground still. But then as it keeps on going by, then the pitch gradually lowers. And that is why. So you see, I've got a formula there on the board that says velocity V total. And actually, this is when when the sound source is traveling towards you, it's V total equals the velocity of the wave plus the velocity of the source. So that's what I showed you, where we had a 20 meter per second vehicle traveling this direction and the sound wave traveling toward the person. Then you have the effective velocity is the sum of the velocity of the sound and the source. And then when the vehicle is traveling away, the speed is the difference of the sound wave and the source speed. So when it's traveling away, the V total is the wave speed minus the source speed, which is exactly what I showed you. Okay. I can actually make my slides, put my slides on email. I can turn it into a PDF and send it to you in an email. So if you want me to do that, just send me an email and ask for it. So I'll know, actually, or somebody can send me an email and I'll just email it to everybody. So you get it even if you don't want it. And what you do with it is up to you. Okay, let's talk about volume of sound. And I think this is that's the end of it. All right. The volume of sound. And I'm going to bring out you know what, I should get my other little instrument, simply because it'll work better on the camera. Give me 2 seconds.
There's like 7 minutes left of class. Are we gonna have time to cover all of this?
Possibly.
I think he's dead. He just died. Philip, you're an
He's
idiot.
getting-
Why is it
harmonic.
that the moment Mr. Sears leaves and Finn opens his mouth, the first thing
sniper
you
took
hear
care of it.
is, Mr. Sears is dead. That's the first thing you say. Why?
I struck my guitar.
Thought my sniper got him, but
Oh
it
my
failed.
God, he got a tiny guitar.
Okay. Shh. We only have a couple minutes left. So I brought my miniature guitar. True,
I have
real
a minute.
miniature guitar.
That's a ukulele.
Oh yeah, I
That's
shrunk
4
the
strings.
guitar.
Yeah, it's a ukulele. And yes, I can play this one too. I don't know all the chords on the ukulele as well as I know guitar chords, but I do play this one a little bit as well. So the songs I play on it are totally not ukulele songs though. Anyway, let's see. The amplitude, or I'm sorry, let's see, the sound wave or sound volume is related to the amplitude of the wave, as it says there on the screen. Amplitude of the wave determines the amount of energy in the wave and therefore the volume. And the best way that I can think of to observe the amplitude of a wave is to use a stringed instrument, because you can actually see it. And that's actually, you have an experiment for that as well. I don't remember if you're supposed to turn that one in. Did y'all do that one this week too?
The string? No.
We only did 14.3.
I only did the bottle one.
Okay.
And the candle flame thing.
I'm going to switch over to switch off the slides. So anyway, what I want to do just real quickly is just show you the difference, but I'm going to get pretty close to the camera. So this instrument is different because the big string is actually this one right here. That's the largest diameter string. So when you actually strum the strings open, it makes sounds like this. I'm trying not to do it really loud because it might just
it will alert the children.
No, you might want to actually turn your volume down. I'm going to do it initially real quietly so you can actually see, and hopefully this will come through on the camera. And you did you do have an experiment about this in the book. I just don't remember if you'll actually do it. You might have to turn it in next week. But essentially, tell me if you can hear this. Can you hear it?
I heard it.
I heard it
for a
minimally.
little
Yeah, I heard it.
Like
I
in
heard
the
the-
beginning,
It was
was
very
audible.
faint.
The first string was good. All the others I could not hear.
Well, I'm just playing the one string. So let me do the little one. This is the highest string. I'm going to play it now. Can you
I
hear
heard
it?
that. Yeah, I heard it.
I heard it was very faint.
Sorry, I
Can
was
you-
yawning. Can you play it again?
Can you see it? Can you see it moving?
Again, I wasn't looking that closely. Yeah, I can.
Can you see it vibrating?
Yeah.
Not really.
It's like
It's not
magic.
coming through that well on camera.
Here's how
Okay.
you tell when his finger pushes it down originally.
Well,
That's
yeah,
it.
you can see that I'm plucking it, but you cannot really see the oscillation of the string. You can't see the string moving.
I can.
Like, I can see it moving when you're touching it with your finger.
Right.
I can, like, it moves a little bit when you can hear it, but then it stops moving. I don't think it's coming through that well on camera.
All right, so I'm gonna see if I can put some light on it and then put the strings pretty close to the camera here. So you really can't, on the camera, you really can't see that. Now in person, actually, I can't even see that string vibrating with my eyes. Because the vibrations, even I'm plucking it very gently and it's definitely making a sound. So we know it's vibrating, but you can't see it. So it's very, very soft. The sound is very soft. Now, if I actually, in contrast, if I pull it harder, I bet you saw that a little bit. And hopefully you didn't pop your eardrums, because I suspect that was pretty loud. But you can see just for a moment, you can actually see it. You can see it vibrating. The bigger one might actually vibrate more clearly. So do you see it make that shape? Right up here, you can actually see the vibration.
Yeah, I saw that.
Yeah.
So
We have
but
like
it's
1
this-
minute left.
much louder, right? Let's do that one at a low volume. You can see me pull the string.
Yeah, I can see it vibrating.
Barely. But if I play it loud, you can really see that it turns fuzzy probably on your camera, and then it starts to, it kind of slows down a little bit. So the point is that if I pull the string hard, then you get large vibrations or large movements of the string, and you get louder sound because it's putting more energy to the sound. So you can actually visually see with a stringed instrument, you can actually visually see the difference between making it play loud and making it play softly. If I play softly, you can barely see the vibration of the strings, but you can still hear the sound. If you play it loud, then you can see the strings vibrate a lot. Really can't, it's too far away from the camera for you to be able to observe that, but you can definitely, if you have one, you can try that. I think that's our experiment for next week, maybe. I'm not 100% sure. And yes, we are out of time. So does anybody have any questions? That is a 8th grade level survey of sound. And next module, we are going to start talking about light, which is also a wave. So we've got set the tone. That was a good pun. Set the tone already for talking about the waves associated with light. And we'll get into that. Light is a little bit more complicated than sound. It's just a little more involved.
Are we gonna do the end of year party like once the quarantine is over?
Can we do what?
Are we going to do the end of year party thing?
I hope so. I hope so. I'm not overly optimistic about it, but I really hope we can.
My dad said that he has a friend like in the governmenty people, and he said that according to their like calculations and such, in 2 months Texas will be like New York. So they say it's going to get much worse.
Optimism. I'm gonna be gone next year. And
Have
that
you
really
been
stinks because this
drawing
was my last
Batman
year. I
this
was,
whole
like,
time,
looking
Cedar?
forward to being able to like, I don't know. But now like my last time with sim science is ruined. And I've known people in this class for 5 years.
Don't worry, Finn. You're not the only one.
Guys, I just drew Batman.
Wait,
I'm
Henry, you're
leaving
leaving
too
too?
next year.
Yeah.
Batman looking.
We're moving to
not
West
happy.
Virginia or Virginia or Maryland.
Wow.
Either way.
Wow.
Wait a minute. So your mom won't even be teaching general anymore?
Nope.
Well, it's
Oh
good
wow,
for hearing
that's a bit of a bomb drop there, Henry.
Yep.
I didn't even know that.
I'm just going to high school.
We'll have a going away party for you.
Yay.
Well, and actually, here we can try this. I would actually love for us to be able to meet at some point again, even if we can't meet for the end of the year party. Maybe we'll put together something during the summer because I think that would be great. It's been everybody's going to be ready to get out and do some stuff by the time summer gets around. And hopefully, I would say that I'm not going to listen too much to the government-y projections. We may be under quarantine for a long time. We may not. I don't know. I'm not going to worry about it too much. I'm going to try to keep my head down and keep praying, keep working and doing what I need to get done, and encourage y'all to do the same. Don't get too caught up in projections, because the reality is, government guys, there's plenty of smart guys that are doing the government or that are working in the government, and they don't know everything, and they can't make predictions because nobody knows what the future holds except one person.
I guess
that would be God. So put your trust in him, do what you need to do, and keep on the best thing that any of us can do is pray like crazy, which, wake up in the middle of the night and just pray. Get up in the morning and pray. Before you go to bed, pray. When you think about it, pray. I know some people from my church, an entire family that's missionaries in Spain, their whole family has coronavirus. So it's a little bit scary, but we can't make future predictions of the future. We don't know. The weatherman can't predict tomorrow's weather very good, so they aren't going to be able to predict this either. Also, another thing is that China is opened back up. So they're starting to open things back up in China where everything started. Now, it has been a while, and so we'll get through it. Everything may be very, very different afterward, but we'll get through it.
I have one more question. Okay, I know that there were some people, I don't remember everybody, but who was in the astronomy class taught by, I think she had blonde hair. You remember her? Raise your hand if you were in
Mrs.
astronomy.
Tara. Mrs. Tara.
Mrs. Tara.
I
Yeah.
goes to my
Remember that.
church now.
Ew.
Nice. Okay, wait, raise your hand if you were in that class. Nice. 4 people. That's like a little bit sad but a little bit happy. That's all I had.
All right. Well, I'll say y'all have a good weekend, and we'll see you next week. Same channel.
Bye.
Bye.
Bye-bye.
Bye.
See you on the flip side.
Goodbye, science fam.
Sterling, that was the best outro ever. Oh.
Yeah.
Sam, are you in like Mexico? Why does it look so much like Mexico? I can just like sense it. So lighting.
What? Why
It
you
looks-
coming? Mexico?
It looks like you're in Mexico or something.
What makes it look like I'm in Mexico?
You have Mexican, like ceramic star thing. You have Mexican pottery on the right. You have a fan.
What? What are
Blowing?
you seeing as pottery?
What?
I have no pottery.
What is this thing on the left? Your left. That looks like a pot. Yeah.
This?
Yeah.
That's my headphones.
Weird looking pot.
It's a ceramic headphones.
Those
What
are
about on
my
the ceiling?
headphones.
The
And then
red
I
star
got
on the ceiling?
the headphones to my computer.
Nice. The star though. Yeah.
I just put stars on the ceiling.
Interesting.
I had
All right
stars,
then.
red stars, so I put them on the ceiling.
Luke,
See
my
ya,
phone.
man. Have a good weekend.
Yeah.